Okay, let's get started. Okay, 13th week, digital design and fabrication and design presentation video. We have two topics for today, okay? Today's topic, as I mentioned, two topics, okay? Digital design and fabrication, something beyond digital design, as our course title literally means digital design, okay? And fabrication, that's today's first topic. And get back to our planned work, video-based design presentation for your final, okay? And next week, we will have special guest lecture, okay? And then move on to the final project development, kind of last chance for your final project preparation, okay? Prep for the final. And then move on to the final, okay? Here I simply list up the scheduled guest lecture, okay? Actually, I intended different time, different day, but I determined we're gonna have this guest lecture, Revit-enabled, BIM-enabled interior design studio cases in the US at the beginning of the class next week, and then 2 hours this class and 3 more hours with me, okay? So next week 5 hours, okay? If this one going to be at the end of the class, I'm not sure you guys are here or not. But anyway, this class scheduled, and I mentioned even in March, okay? Okay, briefly again, final project description, okay? 720 PhD, at least 1 minute. My recommendation, 2 minutes or even longer, okay? Due date, due time, you have to keep in mind for in time delivery for this final. And fortunately, now I posted entire previous works in class website, okay? Okay, this is our class website, okay, Google site. At the front page, I posted 2004, 3, even 2012, okay? They are all sample video files. Let's open this one. You don't need to have any permit. They are all public, okay? So you can access previous students' example for the final presentation. And this one, okay? You don't need to open now, okay? After the course, not now. I like to show you just how to do that. Another one, take a look at this notice. Final project page on left page. This is your final project page. If you click this, you can find out final project for this class, okay? And your names, okay? Your names. Your video supposed to be posted below your name, okay? Before posting on this page, you have to generate your video and upload onto YouTube, okay? For doing that, I simply posted instruction, okay? In that final project page, simply click edit in this page and place your YouTube video under your name. That's it, okay? Until that time. And then you can see all together at the end of this semester. Okay, let's get back to today's topic. Here I list what to do today. Lecture first, digital design and fabrication. And we're gonna print out actual thing, okay? That's why I brought this 3D printer here and bunch of examples. We will do something actually in the lecture hour. And then, as always, I like to bring your attention to some skillful techniques in 3D Max, okay? So only 3 simple submissions, very simple. And then move on to some software installation and video-based presentation techniques. That's not that difficult. Just you need to take care of what to do, how to do. So today's lab exercise hours, no submission for video making, but one assignment, your storyboard. We're going to talk in lab exercise hours, okay? Let's move to the lecture, Digital Design and Fabrication. Okay, to make computational models for your design, that's our kind of routine, regular work, right? Sometimes all the night, you are working in front of your laptops for making this kind of computational model, okay? Interior design, building design studio, product design studio, furniture design studio, whatever, okay? In design studio course, you have to bring your ideas, and that should be actualized in computer virtually using one of the computational models, sometimes SketchUp file, sometimes 3D Max file, Rhino file, Revit file, what you have learned this semester, okay? This is computational model file, and then you can generate plans, elevations, sections, PowerPoint slides to describe your design, concept, approach development, and so on, and some good quality rendering for final presentation or some intermediate presentation and so on, okay? So-called design visualization, representation, and presentations. Plan drawings, design slide, rendering, videos. This is your final, okay? But my question is, what's next, okay? In regular design studio course, this is formal routine, and sometimes very iterative, okay? Iterative, kind of never-ending cycle. But actually, you know what's next, right? Realization of your design. That's the end of this process, okay? So building surface, facade, building interior, furniture, some material, interior color, plan, and so on, they can be realized in specific particular site, real world, okay? This is the realization. How to realize? Of course, you know what's next. Of course, we have to construct, erect, building, and components on site, okay? On site means at that particular location, okay? Or sometimes particular spaces in existing building for interior project. This is structural construction picture. And actually, in this kind of bigger picture, there is one more thing, okay? Fabrication. Okay, the process usually going to flow like this way, but also this kind of flow you can find out. Fabrication, especially shop fabrication. The term shop here means factory, somewhere, some specialized place, but this is not on-site, okay? If we need to build this kind of panel structure, we don't need to make this one on-site, okay? We can make that in specific shop, and we can transport to the site and install it, okay? Simply think about furniture. We are not making furniture on-site, okay? We just simply deliver, transport furniture. And prefabrication. Prefabrication means precast concrete, precast material for floor, walls, and so on. They can be made in different place and transported to on-site. And rapid prototyping. In your design studio, after presentation, after computational model making, we usually make our prototype model, okay, mock-up model, using foam board, papers, or some wood, and so on. Mostly handmade mock-up models, okay? So today's topic actually is here, fabrication, okay? Especially digital fabrication for rapid prototyping or mock-upping model. Sometimes they are just mock-ups, but sometimes they can be installed on-site for realization of design, okay? So let's take a look at a case study first, okay? last summer's Georgia Tech example, digital design and fabrication. Let's take a look at this process. Okay, digital design and fabrication. But actually there is one more thing, okay, between those two phases. So far, this is our final digital design, okay? But if you have to fabricate, if you have to make this one using digital machines, devices, we need to know how to adjust model can be fabricable, manufacturable, okay? That is so-called simulation or some modification for fabrication, okay? In this stage, Rhino, Grasshopper, SketchUp, 3D Max, Rabbit, any type of software we can use. And this stage, as you may know, CNC machine, water jet, laser cutting, 3D printers, and a bunch of more devices for fabrication. But in this stage, we need some more applications, such as AlphaCam for simulation or some 3D printing specific application. We're going to deal with some example applications today. Anyway, this project is simple. This one is 1 inch by 1 inch wood panel, okay? This panel is going to be cut by using CNC machine, and then this is final product, okay? This kind of interior panel is going to be produced. That was the purpose of this project. And total 9 groups and some several design alternatives generated. In this stage, all they are computer generated models and design examples, okay? This one, another one, something skipped. But anyway, as you always working on, design concept is here, and some progress development at this time, it's Grasshopper on top of Rhino, and this kind of particular geometry created, okay? Next phase is to realize this one using machines. So before doing that, they made this kind of design development approach and concept description and doing some simulation. This is specific software for simulating and evaluating this model for making this actual physical model, okay? Let's take a look at this process example. This is software level simulation, preview of actual making. This one is moving around. And this is the plate of the CNC machine. And this is actually the working on by using the drill in this CNC machine. CNC means computer numeric calculation, okay? So after that, remove some support part and adjust final product, and that's it. So we basically generated this kind of wooden shaped panels, but something more. This is plastic thermoforming structure, and even we generated some concrete, and we used some laser cut layered objects like this one, plastic things, and some example of 3D printers. So in this kind of CNC machine, today you're going to use this kind of application, okay? And if you want to use 3D printers, you have to know the concept of this kind of mechanism, okay? There is one more thing, such as CNC machine. We have to know how to control the behavior of machine, okay? Thankfully, this behavior is really complicated, sophisticated. It's not easy to understand, but there is software application, very good application. What you need to do is simply load the geometry and some adjust options. That's it. Anyway, this kind of behavior should place object on precise location, control moving speed, and move up and down precisely, and jet material in 3D printer's case, okay, and so on. Something not that easy. Let's take a look at demonstration video regarding this actual fabrication project. This is the screen of that application and the demonstration. Okay. There was the plate, and some different drills can be used for physical manufacturing for this one. At first, very thick drills can be used for making this some big structure, and then mid-size drill can be replaced, and it can make some contour. Okay. At the end, the structure going to be generated after cutting out this perimeter part. So this is actual demonstration of the construction. I skipped mid part and some minor configuration edges, and then this one going to be fabricated. Okay. And let's take a look at next demonstration, physical. Okay, this is CNC machine. And the machine is now working on cutting out the structure. This machine is very good for manufacturing some wood products. Okay. Let me skip some part of the video. And if you see, there are a bunch of different type of drills. Machine automatically replaces that drills according to the operation. This is the control. As you see, XYZ coordinate system, okay? Very precise XYZ location controlled by computers. And this is the software to simply import the geometry for making using CNC machine. This device is kind of cheaper one, around 40,000 US dollars. Now it's working on to produce that product. And let's take a look at the last one. Prefabricated structure, and the machine is going to be placed, and the drill prepared, new drill, and it's going to cut some perimeter side of the unnecessary part. They're going to be removed. Okay. It's moving back and replace the drill if needed. Okay. So this is the simple preview of the CNC machine, and this is the final products. They are not simple screenshot of the geometry. They are all the pictures, okay? Physical pictures. Take a look at this one, okay? Fingers. Holding them and take pictures. They are pictures, not geometry, okay? So physically generated. This is thermoforming plastics, concrete, okay? Concrete mold, and water jet cut plastic, and CNC wood structure. And I just bring just one example, okay? This one. This is actually mostly they are MDF, medium density fiber, which is kind of cheap and heavy wood structure, mostly for furniture. But this is real wood, okay? That is why this one has some patterns. You're going to take a look at all my examples for today, and some laser engraving, okay? Hanyang University, Georgia Tech, something like that. So this is a physical markup example for CNC machine. I brought the example today, and all others are listed up here, okay? And actually, in terms of digital fabrication design, there are amount of more applications, but I like to bring your attention for 3D scan, okay? For kind of first stage. So as you know, we demonstrated laser scan in this room and in this building last year. That kind of laser scan can easily acquire the given existing geometry by using lasers. But this kind of device also laser scanner, okay? So simply scan your face and you can make this kind of structure. We're gonna make this structure today. I need volunteers, okay? I brought 3D scanner and example, okay? This is the example for structure. And here is the laser scanner, okay? So I'm gonna use this one for physical markup, 3D printing by using this laser scan. But actually, this is actually for fun, okay? Just for fun. How to create geometry by using this kind of laser scanner and print out for your face. But actually, in our domain, we can use something like this example. As you know, this is picture, okay? Digitally fabricated model. But we don't need to use laser scan. You know 123D Catch, Autodesk app in iPhone or any Samsung phones. So taking pictures by iPhone, lots of pictures, okay? 12, 16 pictures in sequence. And then this is 3D geometry, okay? Auto-generated geometry by using photogrammetry. I introduced you this one last time, okay? Drone took pictures and photogrammetry technology can make some geometry. Also, this one can be reconstructed, okay, by using this kind of 3D geometry. So if you import this one into AutoCAD or some specific 3D tool, as you see, all they are 3D mesh, okay, editable mesh. And then you can easily convert this one into DWG file, representative CAD file, and bring it into Revit as a family, your custom object, okay? This is not a wall, this is not a furniture, this is not a lighting, this is not a door, but this one can be applied for one part of your design. At this time, some structural panel design work, okay? This is Revit. In Revit, you can click wall and generate walls, but if you click component, and if you load this one into your project, this is one of your library for your design, okay? So if you create this design by using Rhino or 3D Max, anyway, you can import and you can make it family, but you can scan it. You can scan by pictures easily, okay? That's one way of creation, applying Revit family into the design project. This is kind of applicable example, I think. And next issue is 3D printing, a new way of digital fabrication, okay? That is why I brought this one today, 3D printing. And let's take a look at this one, preview. As you know, this is 3D Max interface. And as you see, this structure is very simple. You know how to make it, right? Take a look at this geometry, not that complicated, nothing special. Here is the outer geometry and inner geometry. It's placed exactly inside of this structure. Nothing so special. It's just the 3D Max model. But let's take a look at the diameter of the outer geometry. This is B, and the maximum size of inner geometry radius is A, and simply A is bigger than B. So what if you create this one by using 3D printers? Inside object never come out, okay? It's always inside of this geometry, but it's moving, okay? This one, okay? Outside the geometry has the same shape, but inside of that, because of the shape of this geometry, as this print out, this one can be printed out in this shape, but after that, this one is moving, okay? But never come out. What if you want to make this one without 3D printers? No way, okay? There is no way to make this one. You have to make this one and cut half and place it and glue it. That's regular way of our conventional manufacturing method, okay? But this one originally created in this geometry and printed, okay? This is one simple example for that. And I like to show you this demo video. This is time-lapse video, okay? For this one. As you see, here is the plate. This is time-lapse, okay? 30-second, one picture. So anyway, total 2 hours. Plate placed on top and going down, and XY movement and nozzle will make products. As you see, exterior geometry and interior geometry, they're going to be settled in this way, but after that, this one going to be move around inside object. 2 hours, okay? 2 hours time-lapse video. And the picture for this one is moving, okay? This one cannot be removed, okay? Moving. No cuts or glues used. But actually, this example is one of the examples in broad example of 3D printers. You may find out some news media, Facebook, someone always saying 3D printing is kind of very challenging and really innovative technology, but you don't know why, especially in terms of geometry. Let's take a look at this geometry, okay? Rectangle shape, and they are overlapped, but nothing touched, okay? So if you print out that kind of geometry using 3D printers, this one can be generated, and this one is moving like this, okay? Something like fabric, something like chains. This is kind of 3D chain. Today, we're going to print out this one, okay, by using this machine. Okay, how to make this one without cuts? As you know, the simple chain has cut and connect each other, and some mold or some additional work required for make that chains. But this one originally connected without any cuts or any gluing, okay? So how to actually print? That's the question for today's 3D printing and digital fabrication issues. And I would like to let you know how to use this 3D printer. And then we're going to use 3D printer by using this scanner and other geometry we're going to use. Anyway, this is the software named Simplify 3D for this 3D printer. This is not 3D Max. This is not Revit. This is not 3D geometric modeler, okay? This one only imports 3D file, okay, like this one. Simply import this geometry and make some type of simulation for manufacture and save this output file, G-code file, into this memory and simply place the memory and print out. This one doesn't need to be connected to computers, okay? No computer needed. Your computer, this application is kind of licensed. Only this machine and another machine in device room, 2 machines have this application, okay? Licensed. So you can make this kind of geometry anywhere by using 3D Max, Rhino, SketchUp, whatever, and save that into OBJ, object file, and convert that file in this application into G-code file, and place G-code file into this machine. That's it, okay? So this is the interface of that application. if you open this application, this is something like 3D cubic shape of 3D printer. So simply open solid 3D geometry OBJ file from 3D Max, and this one loaded. If you double click the model, you can control its scale, rotation, and some other options, offsets, and so on. So adjusting, rotating, and simply click center and arrange, and then you can additionally edit some more options. Temperature, cooling, G-code, very complicated, but you can use some presets. Anyway, after that, simply click this one, prepare to print. If you click prepare to print, and then you can find out this kind of simulated model. Okay, the green line, red line, they are all the movement of this nozzle. Okay, so you can export that G-code file. G-code file contains the geometry and nozzle's movement, precise location, speed of movement, and how much material should be jet, and so on. Some behaviors recorded in this file. This is the file you need for 3D printout, or even CNC machine, whatever, okay, for fabrication. So let's take a look at some demonstration. Before doing that, let's take a look at this one video as a demonstration. This is the application, okay? If you click play button after generating G-code file, nozzle is going to move from here and small line and draw some structure. You can control the speed, okay? If you change preview mode faster, and then this one shows you like this way, okay? How to print this object. My example today, this one, okay? So if you're zooming in, red line shows you some movement paths. And let's take a look at another example video. On top view, you can see the inside of the structure, okay? Let's take a look at the structure. Outer boundary has the structure, but no, we don't need to feel 100% solid inside of the object. Some structure, okay, they can be hollow, but it should be sustainable, and automatically this one generates some interior fill, okay? But anyway, this is solid 3D model, and this one can be generated like this way. And the outcome of this product is this one, okay? So 3D printing demonstration. For this demonstration, I'm going to show you this demonstration first, or we can use this scanner, okay? I'm going to take some 3D geometry by using this scanner, and another one is, let me open this file. Okay, let me open 3D Max, and I would like to show you which geometry we're going to print out, okay? Okay, I just opened the geometry that I want to print out, okay? This one, okay? If you see this object in this mode, this is top view and front view. Let's take a look at in 3D view. They all cross and overlapped, connected, okay, joined, but not touched, okay? I'm not sure how this one can be printed without any problem. So let's do that, okay? I would like to show you how to print out this one by using 3D printers. Okay, what you need to do is create this kind of geometry. I'm going to skip the creation process of this geometry. Instead, let me show you the process. Export geometry by using object file, okay? STL or OBJ, okay? Object file, OBJ file or STL file can be exported, this geometry. And then, okay, let me export this one and let me save this one into this computer. Okay, let me change the screen. And let me show you this application. This is the application, okay? Simplify 3D to import that geometry. Let me open this geometry, okay? Okay. This is the bed, the floor bed of 3D printer, and this is just loaded 3D geometry from 3D Max. But the problem is this one is bigger than the bed, okay? So I think we need to shrinking the size of this one. If you want to control, simply double click and you can control the scale, okay? How about 0.6? And click center and arrange. Okay, how about 0.665, center and arrange. Okay, I'm not sure this one is appropriately printed or not. But anyway, if you control this one like this way and simply click prepare to print, okay? Actually, some setting files already loaded, so I like to see some preview of the model modification. Let's zoom in. And let's take a look at some process for 3D print. Okay, it looks not bad. So let's try to print this one. Click save the file, and let me save this one. Okay, that G-code file. And that file can be saved and copied. Okay, I just copied the G-code file to this printer. And print, navigate the folder. Okay, start. Now hitting the bed and hitting the nozzle after preheat, and then this one is going to move in out. Okay, you can take a look at some more examples. And I brought some example here. Those two things are very simply generated 3D Max geometry, okay? And this one too. But this kind of certain type of freeform is one good example for 3D printing. But actually, this kind of example, or the one that we generated right now, is much better example, right? This one or this kind of object is kind of very 3D printer specific object, printable, okay? And also I brought this one, another 3D printer. you can print out this one using the structure. Let's take a look at live demonstration, okay? You can make anything. Technically, you can make anything. Simply draw on the air, okay? But of course, it's not easy. And as you may know, this kind of 3D printer requires material. The material name is filament, okay? Same size. This one usually ABS, plastic, or PLA. So we have several different type of colors, different type of material, even wood, okay? If you use wood, your final product looking like wood product. If you use translucent soft object, final product is going to be very soft, okay? Okay, heating nozzle, and okay, after preheat, I can load this one and make some 3D print out object. After this one, we're gonna take 3D scan, okay? So that your face or structure can be loaded. Your face can be loaded into 3D Max. Okay, face first, your face, okay? Okay. 3. Okay, just a second, just a second. Just a second. Okay. Okay. For saving time, let's move. Let's take a look at this final model. Okay. Here it is, okay? Okay? But this is texture mapped. If you save this one into, okay, just a second. Save in OBJ file, and let me show you this example. Okay, in C drive, this is your geometry, just a second, okay? This is kind of quickly generated geometry. Okay. Now you are in 3D Max. Okay. Okay, this is one quick example. Actually, I simply skipped some modification or some retouch, some Photoshop-like retouch required, and backside is currently hollow, but this one can be filled with some solid, and we're gonna do that in lab exercise hours, okay? This one is just demonstration. And I'm gonna save this file for you, okay? Okay, that's it. I think now it's time for lab exercise. We're gonna have a break. Let's finish the lecture. And in that time, you can take a look at some examples here, okay? Some series of examples of this digital manufactured object, okay? Okay, okay, it's done. And 3D printing is now working. Let's take a look at how it works, precisely or not.